Hello, in this video we are going to talk about angular momentum and angular impulse. Angular momentum, L, use the symbol L for it, is similar to linear momentum but for rotation. Now, we will call it L, and we have linear momentum, which was P equals to M times V. Now, as we know that M became I for rotation and V became omega for also rotation. So here it was P equals to M times V, as we said, then the angular momentum will be equal to I times omega. I is the moment of inertia in kilogram meter squared, and omega is the angular velocity, which is radians per second. So that's angular momentum L equals to I omega. Now, to find angular momentum of an object at any given point. So L at any given point. It may be hard to use I omega since we have a point, so we have to use another equation. In that case, L, the angular momentum, which is a vector, is equal to R cross P. So here, angular momentum, R, which is the distance or the position vector. It's usually we use it in meters, and P is going to be the moment in kilograms meters per second. So we can see here from this one that the angular momentum is going to be equal to kilogram meter squared per second. Now, if you notice that angular momentum L is a vector quantity, and the direction of that vector is going to be perpendicular to the plane of R and P. So L is perpendicular to the plane of R and P. So in that case, we are talking about three dimensions. R and P, they are going to be, let's say, two horizontal. Then L will be perpendicular to them. That's like in math, you have X, Y, and Z coordinate system. Now, if you want to get the magnitude of L is going to be L equals to M times V times R times sine the angle. As you see, M and V, they are the momentum, R is the angle, and sine comes from the cross product that we mentioned before. So M, the mass, the speed, distance, and this is the angle between R and V. So that's going to be about angular momentum. Now, the second part is going to be about angular impulse. Angular impulse. Now, as we know that uh, angular delta, let's call it delta L, is going to be L final minus L initial, which is going to be the change in angular momentum. Now we have the angular impulse. Angular impulse by definition is the torque multiplied by the time interval. So angular impulse will be equal to integral of the torque dt. That's for a varying torque. For a constant torque, the angular impulse will be equal to the torque times the time. And be careful, don't mix between angular impulse and work. The difference here with time, the other one was with the angle. Now, angular impulse and torque, they will have the same direction. Okay, from this one, what we can see, we can say that angular impulse, as we did for unit 4, will be equal to the change in angular momentum, and we said that also angular impulse is equal to the torque times dt, or a angular impulse is integral of the torque dt. From those, what we can find that the change in angular momentum is equal to the integral of torque dt. For varying torque or for constant torque, delta L is equal to the torque times d, the change in time. So from that, we can say find that the change in angular momentum is equal, or the torque, let's make it through the torque better. So we can say torque is equal to the change in angular momentum over the change in time. And we know that torque is going to be equal to I alpha, or delta L is going to be I omega, up to you which one you want to use. Let's go over L. Delta L, the torque, is equals to, we said that before, angular momentum is L, or I omega, but since it's changing, we will have to put it as d omega. Why? Because if I have delta L, L is equal to I omega, so the I is the same over dt. Now d omega by dt, it's going to be alpha, so it will be I alpha, which is, we go back to Newton's second law. Now, the last part of this one, similar to impulse, if I have a torque and time graph, the area will be equal to the angular impulse. And if I have an angular momentum and time graph, the slope will be equal to the torque. So we are just having the same as what you have done in unit 4, but just switching to torque, angular momentum, and angular impulse. That's it for unit 6.3.